Alright, so my last video didn't record, so let me explain this again. Alright, so what we're going to do is properties of parallelograms. And first let me explain what a parallelogram is. A parallelogram is a four-sided figure in which opposite sides are parallel and congruent. Um, Now these little markings here, these little arrows, just tell you that since there's only one arrow here and one arrow here, that these two sides are parallel, meaning they will never touch if I extended the lines out all the way. And then these double markings mean that only these two are parallel, but that they're not parallel to each other, obviously. Now, um, there are some special kinds that we'll be talking about later. Those special kinds are rectangles. The sides are parallel, and they are congruent, so it still matches. Squares, the sides are parallel and congruent. And finally, the last one's called a rhombus. We'll be talking about that later. A rhombus is essentially a square that's been turned sideways. So instead of having all these 90 degrees, it's just turned sideways. And so all the sides are congruent, but the angles aren't. Now, for the different parts of a parallelogram, the area is just finding the base times the height. Now remember guys, the height means the up and down thing, not this diagonal over here. I'm going to be giving you guys numbers that are going to start throwing you off, and the only reason I'm going to give you those is just so you guys understand that it should be base times height, not base times this thing over here. This is not height, it's the diagonal. Diagonals bisect each other. What bisect means is they cut each other in half. Opposite sides are congruent, meaning if you have one side, the other side is the same length. And then finally, that same side angles are congruent. So opposite angles are congruent. I'm sorry. So we knew the sides were congruent, but opposite angles are congruent, meaning these two angles are congruent. And opposite sides, or same sides, add up, or supplementary, or add up to 180 degrees. So these two would add up to 180 degrees. Now, I'll give you a sec to write that down. Or actually, just pause the video if you need to write it down. To find area, area is base times height. So in this case, remember, we're not using the 9, we're using the 12. Originally, when I started this video, I only had a 7 at the bottom. It doesn't matter where the 7 is. If it's at the top, it's at the top. If it's at the bottom, it's at the bottom. It doesn't matter. It's just we're using one of these two things. Okay, so you're going to take the 7, you're going to multiply by the 12. That's pretty easy. 7 times 12 is 84. So the area is pretty easy to find. Just take the base, multiply by the height, you're done. Diagonals. Diagonals bisect each other. So that means that if I were, here's the first diagonal, here's the second diagonal. If I gave you that one of these half of these diagonals is 5, you would know that the other half is also 5. The reason is that since this has been bisected or cut in half, if half is 5, the other half also has to be 5. Same goes for the other one. If half of it's 10, the other half also has to be 10. So, in total, this diagonal right here would be 20. This diagonal here would be 10. And that's how diagonals work. Finally, you have angles. So, if I gave you one of these angles, let's say I gave you 87 right here. The first step you would know is that the opposite angle, meaning the opposite side angle, is also 87 because it has to be the same number. To get to this thing right here, all you have to do is figure out, okay, so I know this one's 87, and I know both of these, they're the same side angle, have to add up to 180 degrees. So if I know this one's 87, to figure out this one, all I gotta do is take 180 degrees and subtract 87. Once doing that, you realize that, okay, well, 180 minus 87 had to be 93. Knowing that this one's 93, you can figure out this one's 93 pretty easy because opposite sides are the same. Or you could take the fact that this is 87, subtract from 180 to get to this number. Either way works. But that's how bisector, I mean, that's how the parallelograms are. In the next video, I'll explain more in depth of the special type. But for basics, that's what a parallelogram is, and that's what it does.